Good afternoon. My name is Charles Scott from Civil Designer Software. Thank you very much for allowing the time to join us today. I trust everyone is safe and well. Welcome to this month's Open Classroom webinar, which forms part of our Open Classroom webinar series. This series, in turn, forms part of our suite of technical support services and resources created to proficiently assist our existing Civil Designer Software user community and additionally quickly upskill all our new software clients. Please visit our website's services section for a full list of these services. And in the webinar section, find our list of past Open Classroom webinars, which now totals more than 60. Please also visit our FAQ page, which now hosts 315 short, searchable videos created from our past webinars. Videos covering our BIM data files, workflow interoperability, stormwater retention pond design, dealing with GIS data, and even how to best utilize our help desk services. Finally, please visit our client showcase section for more information on where your industry colleagues are taking Civil Designer to. Back to today's webinar, where we welcome back Cameron Boyle. During Cameron's time today, please do not hesitate to send us any questions you may have using the text question messenger service in the GoToWebinar app. Please remember we will be posting a recording of today's meeting in our website's webinar section later this afternoon. So, good afternoon again, Cameron, and please take it away.
Thank you very much, Charles. Good afternoon, everybody. Welcome to today's webinar, where we'll be focusing on the quantities of the different modules within Civil Designer. So we're going to start off with the Survey and Terrain module, where we look at platform or bulk earthwork quantities. I'll then focus in on dam volumes. We'll then move on to the roads module, where we'll look at numerous different options, including the Masshaul, the Cumulative volumes, your Layerwork volumes, including road rehabilitation functionality, things like your Kerb Quantities. We'll then end off with the different pipe modules, so the sewer, the stormwater, and the water. To start off with, we're working inside this project, looking at this blue area. I'm then going to do a platform design, and then we can calculate the volumes. Escaping the render view. Now that we know what the site looks like, I can go and turn off the bitmap or aerial photograph and then turn on the cadastral. Zooming into the platform design, I've already gone and put in the parent platform. I'm going to go and generate the embankments. So I go to strings, string creation, create a child, put it on the outside of the parent, specify I want to grade the embankments to my natural ground line, specify my cut and fill slopes. Now that we've got the toe points, I can go to the properties and go and update the display settings. Pressing escape. There we've got a platform design. Let's look at the volumes. I do so by going to strings, string editing, and selecting the volume option. Specify which string family I'm working with. I can go and specify topsoil to strip, as well as a compaction factor, which not a lot of software programs can do. With the topsoil to strip, it is the depth of the topsoil to be stripped before fill takes place. It is not used during the balancing calculations, but is used when final volumes are reported. Looking at the compaction factor, this is the factor to be applied to the cut material before being used as fill. A factor of 100 gives no compaction, less than 100 gives compaction, and then greater than 100 gives bulking. And I should also mention that with your string volume, Civil Designer uses the triangulation method. Now I'm then going to go and update these volumes for explanation purposes, and then click on OK. Specify where you want the results, and then use this output window on the right hand side. Looking at the results, we've got the unadjusted volumes as well as the areas, and then we got the volumes adjusted for the compaction and the topsoil stripping. Now what I've done for explanation purposes is I've gone and selected that, copied it, and then went to Excel, right click and pasted it. Then I've also gone and put in the values here so I can use it for explanation purposes. What you're about to see also applies to your road calculations. So we got the total cut, and this is the unadjusted volumes. We got the total fill, and then we've also got the area. Then we've specified no compaction, so I put in 100% there, and focusing then in on the 100 mils of topsoil. So I've taken the total cut area and I've times it by the 100 mils to give me the total topsoil strip-in volume in cut. I've then taken the total volume in cut and I've minused the topsoil strip-in volume. So if we were to look at the equation there, just to reiterate what I've pointed out, same applies to the topsoil strip-in volume in the fill condition. Thereafter, if you want to see if you've got excess cut or fill, you take your fill minus your cut and you're left with the resultant. So that applies then just to the topsoil. Then looking at your compaction factor of 95%, you can see I've gone and put in 0.95 there. Looking at the equation, you take your original unadjusted cut volume and you times it by the 0.95 to give you your result. Your fill stays the same because your fill isn't influenced by your compaction factor, and then you take the one minus the other to, in this case, get a fill shortfall. Then put in the topsoil of 100 mils as well as the 95% compaction factor together. Looking at the equation again, you take your topsoil resultant volume and you times it by the 95%. Your fill volume is the same as the full volume used after your topsoiling has been added. Again, here we're going to calculate the difference between the two. So I thought for explanation purposes it would be good to first of all calculate your topsoil strip-in, then put in your compaction, and then show you the calculation with both scenarios calculated. Closing Excel, going back into Civil Designer. If you now want to optimize your cut and fill volumes, you can go back to strings, string editing, balance cut and fill volume. Go and specify the optimization difference. In this case, let's go and put in 5%, which would mean your cut and fill will be within 5% of each other. Again, go and specify a topsoil to strip and a compaction factor. Click on OK. You can see the different colors represent the different cut and fill. So what Civil Design has done is it's taken the parent platform and it's made it higher and lower. It's calculated the volumes until those volumes are within 5%. Click on OK again. Previously we had unadjusted cut of close to 6,300. Now we got close to 57,800. So you can see quite a bit of calculation being done behind the scenes. Nice thing about this function is if I were to go and press Ctrl Z on my keyboard, the optimization functionality is removed. Still sticking with our surveying terrain module, I'm going to go and open up another project, and in this case we're going to focus in on dam volumes. And just to show you what this looks like, I'm going to go and right click and select render view and view it from a different perspective. What I've done here is I've gone and put in a dam wall, and the objective here is to calculate the amount of water or the volume of water we are able to capture behind this dam wall. I do so by going to terrain, dam volume, go and specify water level, which surface I'm working with, your depth increments for your volume report, if you want a CAD output of it. And then also a very nice feature is to create a reservoir output file, which you could then utilize within the stormwater or surface drainage module. Click behind the dam wall, specify where you want the result, and then click on OK. So there we go, close to 226,000 cubic meters. If you look at our project, you can see that this water level is represented by a polyline. Now if I go to the properties bar, you can see that polyline already has the water elevation. So using that, I can go back to the strings functionality, as in the function that I first showed you. Go to string creation, this time a string from polyline, go and click on the polyline and then pick up the elevation from the polyline entity. If you want to go and view that in 3D, again you could go and right click, select render view, change your zoom view, specify which settings to use, and then go and right click and select circle around. Not only have you calculated your dam volumes, but you can also then go and view it in a three-dimensional format. Not to forget that you've already gone and created a stormwater reservoir file. So just to show you that, if you go to edit, reservoir, go and specify the file that we've just created, and then click on the storage discharge profile. So there's your depth versus your storage information. Another very nice volume function within the surveying terrain is your surface maximum. Let's take a closer look at that. If I were to go back to the terrain module, go back to terrain drainage, flood levels. If I were to go and select surface maximum, this flood level elevation will change. It will then take the highest elevation represented by this red portion in the northern side. It will use the same elevation around the perimeter of our site, and using that elevation it will calculate the entire volume of the site. It may be just the function you're looking for when you calculate your borrow pit volumes. So click on surface maximum. That is the highest elevation. Again, you can go and specify your depth increments, how you would like your CAD output to be represented, and on which layer you want to save the information on. There's your volumes, 85.6 million cubic meters. And then just to right click again, render view, it helps to explain the function in a little more detail. So there we got the highest point. It uses that elevation around the perimeter of our site and then calculates the volume within that perimeter. And then close these two projects. Then we then move on to road quantities. Taking full advantage of Civil Designer's integration and opening a project that already has the roads, the sewer, the stormwater, and the water modules. I'm going to start off by turning off the water, the storm, and the sewer modules. Looking at the road settings, turn off the transparency. We then focus in on this longer road, which is Victoria Road, and it's a dual carriageway. Selecting it and pressing escape. There's numerous volumes we can look at within the roads mode. Let's start by going to area volume, cumulative volumes. I want to show you the difference between your cumulative and your Masshaul volumes. You don't particularly have to calculate the volumes for the entire road. You could go and specify a start and an end chainage. So for explanation purposes, I'm going to go and put in a start chainage of 695, end chainage of 705. With the Masshaul, you'll see that you have the option to specify a start volume. That start volume would be any arbitrary item such as borrow material. You can go and specify the topsoil to strip, which is the depth of the topsoil stripped from the cross-section before your volume calculation. You can go and specify the road prep volume, and this is according to your COLTO spec. And if you're not quite sure what that looks like, there I've got an example. So this is applicable to your dual and your single carriageway. If we look at the single carriageway on the right hand side, when the layer works of the road falls beneath the ground line, then we use the layer work line to determine your road bed. If you look on the left hand side here, whenever the ground line is beneath the layer works of the road, we use the ground line to determine the road bed. Closing that, and then specifying your compaction or bulking factor. For explanation purposes, let's go and put in 95. Remember that this is the factor applied to the calculated cut volumes. Anything greater than 100 implies bulking, whereas anything less than 100 would imply compaction. Here you can go and specify between which two layers, road layers, you'd like to use. And if you click on the down arrow and you don't have additional layers here, you may have to go and solidify your layer works. Alternatively, if you'd prefer to use the newer functionality, you can just go and specify the subgrade option. And in that case, it will be between your ground level and the bottom of your template layer works. Now, remember this diagram because this is also used in your report quantities functionality, where whatever you go and specify here per road, the volume is calculated using these settings over here. Click on calculate and specify where you want the result. If you're wondering why this dialog comes up again, it may be that you want to put in certain chainage values with different topsoil to strip and compaction factors, depending on what your ground conditions are. At the same time, you could also go and leave out a section of road that may be a bridge as an example. If you look at this icon over here, that would lead directly to the hub file explaining what your results are going to be. More about this a bit later. Closing the hub file, clicking on results to output. Now remember, we've just worked out the cumulative volumes. This calculates the volumes yielding a cumulative total of cut and fill. It's normally used to access the amount of material in individual cuts and fills. If we look over here, you've got your basic, and that is before any topsoil and compaction is taken into account. Here we got the cut volumes, and here we got the fill volumes, and then the cumulative volumes. Between chainage 695 and 696, the cut volume, basic, and that is excluding the topsoil and compaction, is 5. Then you take the topsoil into account, the compaction into account, and you're left with a final there of 1.8. Now remember, we've got only one decimal place here, so it's rounded off to the nearest 0.1. Same applies to the fill volumes, where you got your basic, topsoil, and final, and then you got cut for that chainage and the fill for that chainage. If you look at the values individually, here we've got 1.8 as a cut. In the next chainage range, again we got 1.8. So in total you got 3.6. Again 1.8, so you take the 1.8 plus the 3.6 and you're left with 5.4, and so on. That applies to the fill as well. Going back to area volume, selecting Masshaul volumes this time, leaving everything as is, click on calculate, going through the process again. And here you can see the difference. So we've got a cut of 1.5, and that is your total cut of 1.8 minus your total fill of 0.3. So we're left with 1.5. There you can see the difference between your cumulative and your Masshaul volumes. At the bottom here, we've got some additional volumes. These are the unadjusted volumes for your total cut and fill, and then your volumes for your compaction and your topsoil. As mentioned before, if you'd like some additional information with regards to that, with this dialog open, you can either press the letter I, or you could go and press F1 on your keyboard. Then go and select volume calculations at the bottom, There we got the cut volumes, your basic, your topsoil, your compaction, and your final. And if you look at the results explain what the unadjusted volumes are. In addition to that, we also give you a diagram to explain the difference. While we are busy with this Masshaul volume, I'm going to show you how you can go about putting in your Masshaul diagram. I'm going to go and put in a stretch of 100 meters for the road. In order to utilize these volumes in the Masshaul diagram, you need to go and select Spreadsheet Output. Click on Calculate. You can see the file extension here is a LST file. Go and specify where you want to save it. And then looking at plotting the Masshaul diagram, you go to Plot, Generate. Go and specify where to find the sheet file. So the standard Masshaul diagram or graph is found under this path. C drive uses public documents, knowledge base software, sheet files. Scroll down, you'll see there's the Masshaul graph. Go and click on Open. Click on Next. Specify your horizontal and vertical scale. Specify where to find those quantities, and that is the LST file that I pointed out a bit earlier. Click on Next, Finish, and there it is. And then just take in note your end volume here indicates that you've got 364.65 cubic meters of excess cut. If it was a negative value, the Masshaul would represent full shortfall. And then something worthwhile pointing out, if you do use the standard Masshaul diagram, you might want to go and change your grid labels. In that case, you could go to Applications, Sheet File Editor, go and load the Masshaul Graph sheet file, go to Settings, Sheet File Settings, under Long Section, there's an option of grid text, and there you go and specify your interval. Closing that, and then going back to our roads project. Going back to the roads mode, going to Area Volume, and then looking at Layerwork Volumes. Pretty much straightforward, where you go and specify your base and your batter layer and which chainage range to use. Perhaps I should use this opportunity to show you your layer works in your road rehabilitation functionality. So I'm going to go and open up another project. In this example, you can see what the existing left-hand side road looks like. The objective is to go and make the left-hand side road wider and then calculate the additional layerwork volumes used to make the road wider. So let's first of all make the road wider. We go to Alignment, Regression, Extract Strings. We're looking at the left edge, which would be this CAD line over here, as well as the left median. Now, if you want additional information with this type of design, please do find the video on either on our website or on our YouTube channel, where I go into a lot of detail. For now, let's go and switch everything off besides the left edge and the left median. Click on OK. Looking at the left road edge, we're using CAD and we're going to retain the crossfall. So I go and select the left edge, right click, extract string, and then looking at the median information, Same thing, I'm going to use my CAD entities. I'm going to retain the crossfill, go and select the median, right click and extract string. So there you can see the additional widths. If I were to go to section, graphical edit, click on a position, looking at the left edge, this is where the existing white line was, and this is where the new width is. As I go and press page down, you can see the position in your plan view. There we're back to the original median width, and then you'll see on the left edge it becomes wider. Now the objective is to calculate this additional width over here. Let's look at the existing Layerwork quantities. Go back to area volume, Layerwork volumes, go and specify which road layers you are using, click on OK, and let's take a look at the result. There's your left and your right hand side carriageway if you're working with the dual carriageway. You can see that you've got cut and fill volumes and then the total volume. Maybe that you've got different rates on your bill of quantities for cut and fill. So we've divided it into the separate values. Looking at our total volume on the left hand side, we've got close to 19,700 cubic meters. If you want to calculate the additional width volumes, you can go to alignment, regression, extract Layerworks from CAD, go and specify which CAD layer you used for your additional left edge, specify your existing left edge. You can see your diagram's been updated there. Click on OK, and then rerun your Layerwork volumes. So where we previously had close to 19,700 cubic meters, looking at the total volume, we now have something closer to 3,800 cubic meters. And as mentioned before, if you want to see this type of road rehabilitation design in more detail, please find it either on our website or our YouTube channel. Going back to our previous project, moving down the list, we've done Layerwork volumes, looking at Kerb quantities. Here you can go and specify your own range. I'm then going to specify from chainage 0 to, let's say, chainage 750. Specify CAD output, and this is really nice for graphical explanation purposes. At the bottom below this, you can go and specify your own radius range and which pen colors to use. And this is also applicable to your component quantities. Click on OK. OK. And so there's your different Kerb quantities included in your junction design. Just showing you that in more detail. If I go zoom in and I go and turn off the road display, that CAD function that I turned on when I requested the quantities can be seen. There's the different radius options. Where do you go and specify which quantities to work out when you're working with Kerbs? You go to Tools, Kerb Editor, go and load your Kerb group. And then if you select the Quantities tab, you can go and specify which type of quantity you want to work out, which formula to use. So if you want the area of this particular curb, you can go and right click, define region, and then go and select the edges. And this is also applicable to your component quantities. Go and right click to stop and give it a description. You could also go and calculate the weight if you need it for reinforcement purposes. Turning my roads back on. Going back to area volume, we've done the curb quantities. The component quantities, as said before, would be very similar to your curb quantities. The difference being you're also able to work out layerwork quantities for your components. So if your component is, for instance, a sidewalk, and the sidewalk needs additional layerworks, you can include that in your quantities. Just to point out again, if I go to Tools, Component Editor, this is where you go and create your components, and you can go and select the Quantities tab and specify again what type and specify your formula. And then last but certainly not least, inside your roads mode, if we go to area volume, you have the option of report quantities. If you click on recalculate all, you'll see that all your roads will be calculated. And if you go and select the individual roads, it's divided into your areas, your layerworks, your components, and your curbs. If you got the latest results, you'll see that you've got a green tick, and you are able to go and write all to file and specify whether you want a CSV or XLS file. If you scroll down to the bottom, you've got default combine, which would include all your roads within your project. Alternatively, you can go and create your own customized report, where you go and specify which report type. Let's say we're looking at a combo of volumes. Specify your report type and which road you want included, pressing Shift or Control keys. In that case, all the specified roads would be included here. You can, at a later stage, go and edit your report and make changes to it. Also note that in 8.4, you have the option of volume details. And if you go and specify the cross-section as your design data source, it will use whatever layer you specified for that individual road when doing the volume calculations. Moving on to the pipe modules. I'm then going to my display settings and turn off the roads for now. Let's look at the sewer module. As you may know by now, the sewer and the storm module are very much alike. So whatever I point out here is also applicable to your stormwater or your surface drainage module. Before you actually calculate your volumes for your sewer and your storm, you need to go and set up your project settings and analyze your module. So in that case, I've gone and selected the sewer module, and you go to Edit, Default Settings. There you can go and specify in which bedding class you'd like to use. We've got the SABS as well as the British standards. You can of course go and create your own bedding class. When you calculate your quantities, you can look at your design parameters, where at the bottom over here you can go and be more specific with your link lengths. Take note that these reported link lengths are only updated when you run your analysis. You can go and specify whether to use 2 or 3D lengths, and whether you want to use the difference between your manhole centers or your inside edges. Now before I run your pipe analysis, I want to go and make this output bar at the bottom here, which normally speeds up the analysis process. Go back to analysis, run the network, specify to analyze the entire network, and once your analysis is done, you can then go to analysis and quantities. Looking at your quantities, you can see that we've got half-meter increments. Now this is something that you can specify. If you go back to Edit, Depth Increments, you can see the half-meter intervals. Alternatively, if you want to go and specify your own, you can do so over here and then select generate increments. Looking at your bedding classes, you can go back to edit, bedding classes, and as mentioned before, we got the British standards as well as the SABS, or alternatively you can create your own bedding classes. If you do make changes to your bedding classes, you can click on default to revert back to the default values. Going back to our quantity results, I go to view, go and select quantities. So there we got the excavation lengths for your pipe type and size with your specified depth increments with the totals at the bottom. Looking at your excavation volumes, if you scroll to the far right, you'll see that we've also got the option of extra, over, intermediate and hard material, which I'll explain shortly. Looking at your bedding and backfill volumes, your culvert or pipe lengths, and your different manhole depths. Now, going back to excavation volumes, currently we got 0 for extra, over, intermediate and hard material. It may be that on your site you've got quite a bit of rock and you want to include those quantities. I'm going to show you how this is done. I'm going to close the quantities dialog, go to settings and specify DTM surface. Here you go and specify which surface represents your intermediate and which surface represents your hard material. You can also go and specify whether you want to use your road design when calculating your quantities or not. Now, looking at the intermediate and hard surface, if I go to my display settings and I select those two surfaces, you can see that we've got 0 points for them. Ideally, you want a detailed survey. Now, for demo purposes, what I'm going to do is I'm going to make a duplicate of surface 1 and then drop surface 1 a certain depth and use it as my intermediate and then my hard material. Just to show you how that's done, I'm going to go to my survey mode, go to editing and select duplicate surface. Specify I'm working with surface 1. I want to duplicate it onto the intermediate surface. Currently they're very much the same surface. Then I'm going to go and apply a constant to the intermediate surface. Click on select, specify surface number 2 and go and put in a height constant. As mentioned before, you'd probably want to be a little more accurate than just putting in a value over here. So in this case, I'm taking surface number 2 and I'm dropping it by 1.2 meters. Doing the same for the hard material, so I'm going back to editing, duplicate surface, put it on the hard surface, and then also apply negative height constant. And this time for surface number 3, hard. Having done that, you might have to reanalyze your network. And once you reanalyze your network, you can run your quantities again. If we go back to excavation volume, scroll to the right, you can see now I've got extra, over, intermediate and hard material. Moving on to the last module, looking at the water or the potable water mode. Starting off by going to settings, water specific settings. There again you can go and specify your intermediate and hard surface and whether you want to use the strings model in your design process. If you go to settings, select pipe defaults, there we got our bedding classes to go and choose from, as well as a trench category. If you want more information with regards to these categories, I'll show you where you can look this up. Go to Tools, Catalogs, Trench Categories. There's the three different categories: the standard, the battered, and the composite. And this you can specify for the entire network or for individual pipes. You can of course go and create your own trench categories. Just to show you, if I go and close that, go and turn on our water network. While I'm here, I'm going to turn off the sewer network. Select a pipe, right click, water operations, edit pipe data. There you can go and specify the bedding class and the trench category. Having set up your network and analyzed the network, you can then go and run your quantities, where you can go and specify which depth increment to use, or alternatively you can go and customize your depth increments. It may be that you're doing this for labor costs, so you can go and set your own defaults and get them back at a later stage. Looking at your excavation lengths, you can go and specify particular groups when doing so, or click on what you've selected. Looking at your excavation volumes, including your extra, over, intermediate and hard material, and then your bedding volumes. Going back to analysis, selecting bends and junctions. This presents you with your pipe information with your bends and the coordinates, your horizontal, vertical, compound angles, as well as your fittings. Bends in nodes, there's your diameters and your bend angles. Junctions, summary of bends, which really makes it nice not to have to count them individually on a drawing, and then a summary of other fittings, including end caps. And then to finish off with, also give you the option of your connection quantities, looking at single, double connection, short and long, number of saddles, as well as your pipe lengths. And that, ladies and gentlemen, in a nutshell, is what your quantities within the different modules is all about. If you've got any additional questions, please don't hesitate to let us know. Until next time, cheers for now. Back to you, Charles.
Thank you very much, Cameron. That was awesome. And thank you very much to all of you who attended today's webinar. As Cameron just mentioned, should you require any further information with regards to Cameron's demonstration today, Civil Designer itself, or you would like to request future webinar topics, please use the email address listed on your screen right now. Please also visit our website and follow us on LinkedIn. Once again, thank you very much for your time today. Have a great afternoon, weekend, and goodbye for now.